So this is part 3, and unless you have already studied this many times before, I would advise you against trying different shapes more than that before you digest and understand what we have already finished. So we have finished the linear shape like carbon dioxide. It has a straight line shape. The angles are 180 degrees between the different bond pairs. And here, this is one centralized. So we have said this is AX2. This is one centralized atom. So I have 3 atoms around it, and I have one lone pair of electrons. So I will say this is one lone pair of electrons. I will say L. L means one lone pair of electrons. Let's make this as a sign between each other. We'll not use anything like that in the exam. AX2, AX3. And then I have AX2, but this time there is 2 lone pair of electrons. I'm going to say this is 2. The angles here is going to be 107, and the angles here is going to be 104.5. So 107 is the angles and 104.5. The last one that we have taken is the trigonal planar. And if you remember, we said that the angle is 120 degrees. The trigonal planar is with anything like boron, which is the central atom, and 3 atoms around it, and 3 bond pairs without having anything in between lone pairs. So this is going to make the 120 famous angle in between. The next step is just to keep practicing many examples like that, which is going to help you make sure that you understand and digest this very well before we can move to other shapes. The next recommended shape is going to be the tetrahedral shape, but I will just take this after a few examples. One of the reasons students are facing some trouble in the shapes of molecules that they are not able to draw the electron dot diagrams, or what's known as the Lewis diagrams. If you are not able to draw the structure of the molecule and know if there are lone pairs or not, and how many atoms are around the central atom, it will be difficult to move to the shapes of molecules. I advise against doing that without knowing how to draw the shapes of the molecules. There's a specific video which is done for the Lewis diagrams. You should always go back for these videos. One other example for the linear is the hydrogen cyanide. There is a triple bond between the hydrogen here and cyanide, which doesn't make any issue. You just consider that this is a single bond, the same way this is like, for example, between H and Cl. So this forces it to have a 2 atoms only. So this carbon is attached to this nitrogen. No, I didn't draw this correctly. That's why I was just telling about the Lewis diagrams. This is the hydrogen, and there is triple bond here. You see the central atom, and there is 2 things around it here. It's forcing it to have, because there are no lone pair of electrons here. There is no lone pair of electrons. The carbon has already finished the 4 electrons. So it's a central atom with 2 atoms around it. There is no lone pairs. We said that this shape is going to be linear, 180 degrees. The beryllium hydride, this is BeH2. The beryllium is there in group 2, has only 2 electrons to bond with the hydrogens. There is nothing else, no lone pair of electrons, nothing. Central atom, 2 atoms around it, and 180 degrees, a perfect linear shape. The carbon disulfide, the carbon is here making double bond with each of these sulfur atoms. So the CS2, very famous examples came before in a past paper, a central atom and 2 things around it. Please always remember that if you are dealing with a single bond or double bond or triple bond, this is considered the same thing. So 2 things. Do you remember saying 2 things around the central atom, 2 electron clouds? If it was triple bond or single bond or double bond, it is just still counted as one only. You see, it's still counted as one thing here. So here I have 2 things around the beryllium and 2 things around the carbon and 2 things around the carbon here. Still consider 2 things only around the central atom, and all of them are still considered in 180 degrees. Take care, the triple or single or double, they are all the same. That's why I brought the 3 important examples. The BCl3, the phosphorus, has 3 chlorine around it. This phosphorus atom is made that there is 1 central atom and 3 atoms around it. But remember that the phosphorus is the same case like nitrogen, it's in group 5. Since it's in group 5, it has 5 electrons, so 3 only are used in the chlorine and 2 which are not used. How I'm going to know that this is going to take this shape? Just told you. This one central atom, three things around it, and one lone pair of electron around it. So L is 1. Again, I said L is between me and you. Don't write L in the exam. Just to remember that there is one lone pair, three atoms around the central atom. You will get the, yeah, what's the shape? Pyramidal. This is the same thing that happened with the NH3, remember? So I have here the PCl3. This is the phosphorus, chlorine, chlorine, chlorine. This is a pyramidal shape. And what was the angle for the pyramidal shape? Very good, 107 degrees. Arsenic trifluoride. This is the arsenic. Same case, has three things around it. Group 5, again lone pair of electrons. Why you are drawing it like that? Because I know it's going to be pyramidal. How do you know? Because you have the arsenic, one central atom and three atoms around it and one lone pair of electrons. I know it's going to be like that. That's why I draw it like that. 107 degrees. So it's still pyramidal. This is still pyramidal. Phosphorus tribromide is going to be the same. Again, phosphorus. Again, 5 electrons. Again, 3 only used in bond pairs and 2 are lone pairs. Whenever you have one central atom, 3 atoms around it and one lone pair. This is the pyramidal and the angle is always 107 degrees. Other than water, there is another example, which is sulfur dioxide. So SO2 is made from one S and there is two double bonds around it. How many electrons are there? There is 6 electrons. I just used 4 only. So there is 2 electrons remaining here. We have said that anything with a central atom and 2 atoms around it and one lone pair of electrons. Is it still one lone pair of electrons or 2 lone pair of electrons? There is one lone pair of electrons. Actually, let me tell you, if there is one lone pair of electrons or 2 lone pair of electrons is going still to be the same. So X2E2 like the water, that's H2O. There is a central atom here, 2 lone pair of electrons. In this case, both of them will be, yeah, tell me the shape, non-linear. So non-linear, if there is one central atom, 2 atoms around it, 2 lone pair or 1 lone pair of electrons. So this is non-linear. The bent shape looks like a V-shaped, looks bent like that. It's not a straight line. It's non-linear. It's bent. It's non-linear. Please always use the word non-linear. And remember the angle. Yeah, very good. 104.5 degrees. Always remember it. Memorize it. Don't forget it. We have SeCl2, TeCl2. This is all in the same thing. Se and 2 chlorines. And in selenium is in which group? Selenium, trillium, sulfur, oxygen, all in group 6. I have 2 lone pair of electrons here. Why there are 2? Because you just use 2 electrons only and there is still 4 electrons remaining. AX2E1 only, there is still 104.5 and the same nonlinear bend shape. Examples for the last shape. BCl3. We took the BF3, BCl3, the same B in group 3. It has only 3 electrons, so it's bonding to 3 chlorine. How did you know the shape? Because I know that one central atom and 3 things around it and no lone pairs. I have the 120-degree famous. It's the same plan. It's the 2D shaped. It's trigonal planar. Please don't get confused. Just repeat seeing the video, repeat practicing, repeat memorizing. You will know it after some time. It will be very easy. It will even be very nice. AlH3, if you want to practice more, is the same thing. Gallium triiodide is the same thing. So this all for practice. Just make sure that you know them very well, and then we are going to move to the next video with some more structures. Don't go to more structures until you are confident with the other ones, unless you are in exam night.